So, you want Claude Code, but you're broke. But first, how does Claude Code even work? Obviously, I'm too lazy to do it, so Lint, explain AI agents.
Sure, AI coding agents, trying to code for you. So, AI coding agents. They're supposed to help you actually finish a project for once. It all starts with your prompt, what you want the code to do. Be specific. For once, the agent's brain then tries to understand your request. Good luck with that. Next, it generates code. Sometimes it's brilliant, sometimes it's, well, a draft. This code then needs to be executed and tested. Just like your code, it might break. Based on the results, the agent gets feedback and refines the code. It learns. This loop continues until the goal is met, or it gives up. Just like you, really. It's not magic. It's just trying to automate the boring parts. Sometimes it's faster.
Thanks, Lint. To add on, our agent runs in an isolated virtual environment. It uses Linux commands to modify a clone of your codebase. This gives the AI full file context without risking any harm to your host operating system or code. And now, I'll start the tutorial. If you're lazy like me, check the description for GitHub. You'll get the full source code for Lint, and it's fully customized unlike this bare-bones version. Let's start with the TUI. We're going to import some basic models. Some of the other imports will have some errors, ignore them, and I'll get to them later. Then we need to make the TUI class. I suggest you name it the same, but feel free to modify. What we're doing here is getting where this is being executed from so it doesn't edit random files in workspace and virtual environment. Then we get the bridge to SSH into the Docker, set bubble to whatever, draw UI, copy me, or feel free to modify. The first line is most important. Anything else is looks. Next, we define the loop to get commands. Feel free to customize, just note what commands do and how to parse inputs. We're getting the command and query/task. This allows us to trigger the agentic coding, accepting the code and leaving TUI. And then we leave an execute command to match. This will be shown in Shell Engine, so don't mind the error you may see. But first, let's code the actual agent import, as I do, and anything else you wish. Then let's make the class and files we want and what we should ignore. And now the init variables, similar to TUI, just remote workspaces and login. Now let's make the snapshot function. This takes the files we're using from current directory and below, while ignoring things in our ignore files. It takes each file and stores them for agent's context. Next two functions make the diff files, so we can see what the agent changed. Just copy the build diff as I write it. This just takes old and new files agents made and stores difference in one multi-line string. Now let's write it with writeDiff function. First, we need to pass in the dictionary of differences, which holds paths and get-style text difference as the value. Then we make a list called lines for markdown file at end. We loop over every path and difference in dictionary and add the path in larger markdown, then the difference under in code block, and an extra line under just for readability. Finally, we open it and overwrite any old text and replace it with the join list, giving us diff.md. All right, run agentic sandbox as the actual core loop engine. First, if you forgot your password, it bails out because, obviously. Then it builds the current project snapshot dictionary, sets up Paramiko, and opens a standard SSH connection into your local running Docker container. Once inside, it opens an SFTP session, forces the remote workspace root directory to exist, and iterates through every file in our local snapshot. It maps the paths using POSIX path since Docker runs Linux, runs a fast mkdir-p on the server so nested folders don't break the stream, and writes our local code block straight into the container Sandbox. Next, it drops into the workspace folder inside Docker, triggers your test script command, and reads stdout and stdrr into a single log string. Then we construct the massive system prompt. We hand the LLM the original files, the terminal crash error logs, the task rules, and tell it to return only a raw, unfenced JSON payload containing the updated code files. Since our models love adding random chats to Markdown, we use our find to remove anything outside of brackets. Finally, we generate a Markdown file and output every command to Sandbox mutations. Now we need a method to accept the agent's code. First, we check workspace for mutations files and add an if statement to return if there is none. Then we read the file and set mutations to that. Next, we loop over relative paths and content in them and set target to the path in workspace and make the files. Or if they exist, we just overwrite them. Finally, we just return mutations applied. That was a lot, so try to tinker around with it. Great way to learn and improve my model. Now onto Shell Engine. This lets us actually execute. All right, persistent shell is how we keep a single shell session alive without losing context. In init, we check your host operating system. If you are stuck on Windows like me, it spawns an active PowerShell process wrapped in UTF-8 encoding. If you're on a better operating system, it boots standard bash. We pipe standard in and out, the input and output, set up a queue, and launch a continuous background reader. Now look at execute command. Before running anything new, it clears queue, because background processes don't have a stop signal. We generate a random string using UUID. We add that unique string marker right after your actual Linux or Windows shell command, paired with a command to echo back the environment's exit status code. Finally, we dump that wrapped command string right into the shell and track the clock using a strict timeout. The background catches the console outputs line by line and adds them to our string array. The instant our UUID marker shows up in log, the shell knows it's done executing, breaks the loop, and returns the console string back to the agent engine. And that's the core of shell. Finally, we have LLM client. This is just boilerplate, so just copy me. We're feeding in your API to actually generate with requests and a basic system prompt. Your query and context. This just lets Gemini communicate with the other parts and be your assistant. Just copy my Docker file on screen. This runs the virtual server to SSH into. And I'll show you how to run it overlaid. Finally, our env. This is how it should be set up. Finally, let's get that Gemini API key. Head to Google AI Studio and get yourself one. It might look a little different since I already have one, but you'll see how. Thank you if you made it so far. Consider subscribing to support more content like this. Thanks. And if you want to see what my GitHub agent looks like, check out I Turned Claude Code into a Cat for full demo.